everyone, welcome to Mona Patil tutorials. Today we are going to learn about heat, which is Chapter 5, Science-1, Standard-10, Maharashtra board. This is part 1 of this lesson. So let's start the lesson heat. So let's recall what points you have studied in previous standard, that is last year. Heat and different type of heat transfer. So heat transfer takes place in three ways: conduction, radiation and convection. Okay, so here we will understand in within a one example. So first, radiation means the heat directly obtained from sun. So between the sun and earth there is no medium, then also heat comes toward the earth. So this is due to the radiation of rays. Then next is the conduction. Conduction takes place almost in metal, and that is due to the atom present in the metal. So you have seen the example on gas. Suppose spoon has kept on something curry utensil, then heat automatically come from one end to another end. Then next is the convection. Convection takes place in the air. Suppose the bonfire is there, so we are sitting around the bonfire, so there is a air between bonfire and we, and this heat convey from air. So these are the three types of heat transfer. Then expansion and contraction of solid, liquid and gases. Suppose solid is given heat, then it expand, and by cooling it contracts. Liquid also, by heating it contract, and cooling it expand. And gases, here also the same, it expand on heating, and cooling it contracts. So difference between heat and temperature, that also we have studied in last year. So let me see the topic to be learned. So what topic we are going to learn from this lesson is the latent heat, regulation, anomalous behavior of water, dew point and humidity, and specific heat capacity. Okay, so let me start from the latent heat. So in latent heat, the concept like latent heat of phase transformation, anomalous behavior of water, dew point, humidity, specific heat capacity, etc. is related the certain phenomena the experience by us in our day-to-day life. Let us learn more about this concept. In latent heat, you can see this diagram. Okay, in this diagram, here the experimentally shown, the burner is lit here, and above it the in beaker ice cube has kept, and temperature to get the measure the temperature, thermometer is adjusted. So students, here while measuring this temperature, the temperature here in the thermometer will be a constant, means 0, till when? Till this ice become liquid or ice turn into liquid. So here whatever the energy absorb here in the liquid or ice cube, it utilize here for breaking down the molecules. Which molecule? Which bound in the ice. Okay, and then it transfer from ice to liquid, and this temperature will be 0. So from this graph also you can see from A to B the temperature time 4 minutes required, and temperature will be a constant, that is 0. And from 4 degrees time 4 minutes, it will slowly increase when all the ice cube turn into liquid, and then the heat absorbed by the liquid to boil the water, and then it convert into vapor. So in this way temperature will increase after 4 minutes. So the constant temperature at which the ice convert into water is called the melting point of ice. Here, the amount of heat energy absorbed at constant temperature by unit mass of solid to convert into liquid phase is called the specific latent heat of fusion. Okay, fusion means bound. Then the amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert into gaseous phase is called the specific latent heat of vaporization. Here are some examples given of substance, their melting point, boiling point, and specific latent heat in kilojoule per kg and calorie per gram. Here specific latent heat of vaporization in kilojoule per kilogram and calorie per gram. So you can see in this table, water ice 0 is melting point and boiling point is 100. Specific latent heat of in kilojoule per kg is 333 and calorie per gram 80. And here the specific latent heat for vaporization means the water will turn into vapor. This phase, okay, this phase is called specific latent heat of vaporization, and it is of 2256 kilojoule per kilogram, and here 540 calories per gram. So from this one example you can understand further all the example. Then next is the regelation. What is meant by regelation? Here you can see the diagram. Ice is given and in between ice the thread had adjusted. Okay, and both the side of thread there is a weight has hang. So due to this weight the pressure will obtain here on the thread on the ice cube, and due to this pressure the temperature here will be decrease and the thread will go inside the ice, and after at the same time the here due to the low temperature or zero temperature this again bound together. Okay, and the thread can be stuck into the ice. So this phenomena in which the ice convert to liquid due to applied pressure. So here pressure has applied and due to that the thread insert into the ice and then reconvert into ice once the temperature or pressure is removed is called regelation. The melting point of ice become lower than 0 degrees Celsius due to pressure. This means that at 0 degrees Celsius, the ice gets converted into water. As soon as the pressure is removed, the melting point is restored to 0 degrees Celsius and water gets converted into ice again. Okay, and this process or this phenomenon is known as regelation. Okay, so you may have seen the gole wala. Okay, how it offer you the gola. The ice pieces are pressurized with the hand and they sprinkle some colors and they offered you like this. So by pressuring with the hands, all the particles, small particle of ice again combine and impact in the one ball. Okay, so this is what an example of regelation. Then anomalous behavior of water. Almost you in a recall also we have studied that on heating the substance is expand. Okay, so in general when a liquid heated up to a certain temperature it expand and when cool it contract. So water however shows special and exceptional behavior. If we heat water from 0 degrees Celsius up to 4 degrees Celsius, it contracts instead of expanding. So this is the special characteristics in water. So it should be expand, but it should be contract, but it is expanding. And at 4 degrees Celsius, its volume is minimum due to the contraction. If the water is heated further, it expands and its volume increases, and this the behavior of the water between its temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water, and this can be studied with the help of this experiment Hope's apparatus. Okay, so here The anomalous behavior of water using the Hope's apparatus, how it can be worked. So initially the temperature of water in the middle of cylinder, this is the middle of cylinder, lower due to the freezing mixture in the outer bowl. So what freezing mixture they have taken are here salt and ice. This is what a freezing mixture almost used in the ice cream seller also. Okay, so since the temperature of water there decreases, its volume increases and its density increases. The water with the higher density moves downward and therefore the lower temperature, that is T1. Okay, so T1 shows the rapid fall in temperature and this continue till temperature of water become equal to the 4 degree Celsius. So when the temperature of water start decreasing 4 degrees Celsius, its volume increases and density will be decreased. It therefore moves in the upward direction. The temperature of water in upper part, that is in T2 thermometer, shows decreases rapidly to 0 degrees Celsius, and the temperature of water in the lower part T1 however remains at 4 degrees Celsius. So for some time and then decrease slowly to 0 degree Celsius. So here this temperature, here in graph it shows the temperature first is decreased till 4 degrees Celsius in the T1 thermometer and then it start to increase. Okay, so this is the graph between volume and temperature of water. So from this experiment we understand here that in the ice region or cold region, how the animal or plants can live under the ice layer. Okay, because here in the pond the upper surface is 0 degree but lower surface maintain the temperature of 4 degrees Celsius, and this is the anomalous behavior of water we have studied here. Then dew point and humidity. So about 71% surface of the earth is covered with the water, and due to constant evaporation of water, water vapor is always present in the atmosphere. The amount of water vapor in the atmosphere help us to understand the state of daily weather. So daily weather can be changed their state or their numericals with the help of this amount of water vapor in the atmosphere. The presence of water vapor in the air makes it moist, and the moisture in the atmosphere is called humidity. Okay, suppose more water vapor will be there, then we can say today is more humid environment. So humidity will be more, and less or shiny day is there, so it will be less humidity because water vapor amount will be less at that time. So suppose unsaturated air at a certain temperature is taken and its temperature is decreased, a temperature is reached at which the air become saturated with the vapor. Saturated means it become condensed or more amount of vapor will be present at the in the atmosphere. So this temperature is called the dew point temperature. The vapor contained in the air measured using a physical quantity called absolute humidity. The mass of vapor present in unit volume of air is called absolute humidity. Generally, absolute humidity is measured in kilogram per meter cube. Because why the unit is like this? The unit of kg for the mass and volume. Okay, volume here, which is unit of volume is a meter cube, and so the unit of absolute humidity will be kg per meter cube. Then relative humidity, the ratio of actual mass of vapor contained in the air for the given volume and temperature to that required to make the air saturated. with vapor at that temperature is called the relative humidity. Okay, so again listen carefully. The ratio of actual mass of vapor. So how much vapor is there in the air for a given volume? Okay, volume means space. How much space is there, and according to space how much mass of vapor is there. So this is what their proportion or ratio that requires to make the air saturated. Okay, and this is what called as relative humidity, and that is why the formula has in for here that percentage relative humidity is equal to actual mass of water vapor content in the air in a given volume upon mass of vapor needed to make the air saturated in that volume into 100. So this is what the formula of relative humidity. Then unit of heat. The unit of heat are joule in SI unit, calories in CGS unit. Now CGS unit means centimeter gram second. Okay, and here standard international. So in standard international the unit of heat is joule, and in CGS means smaller amount, it measured in calories and shown cal. The amount of heat necessary to raise the temperature of 1 gram of water. So how much heat required for 1 gram of water to raise their temperature by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius. So this is the difference showing 1 degree Celsius. Okay, so here this is called 1 calorie heat. Similarly, the amount of heat is necessary to raise the temperature of 1 kg of water by 1 degree Celsius means here from 14.5 degrees Celsius to 15.5 degrees Celsius. But here the amount is big, that is kg. Okay, so here this is called 1 kilocalorie heat, and it is clear that 1 kilocalorie is equal to 1000 calorie. Okay, so first we have seen for the smallest amount, and here is the next in the biggest amount, that is in kg. Okay, here it is in gram. Then next we will see the next period. So we will stop here, and I hope you understand this explanation. So thank you for watching this video. If you like my video, then press on the like button and subscribe to my channel and press on the bell icon for further notification. If you want to watch my previous videos, then check the I button or check the description box in which I have provided all the playlist of my video. If you have any problem regarding the lesson, you can write in the comment box. We will meet in the next video. Up to then, bye bye. Thank you.